Now our next topic is preparation of benzene. Benzene was first isolated by Michael Faraday from the cylinder of compressed illuminating gas, which was obtained by the pyrolysis of whale oil. Further, it was obtained by the help of Hoffman from the coal tar. Arenes are generally present in the light oil fraction of the coal tar distillation. By the help of suitable method, we can obtain benzene. So first preparation of benzene from ethine by cyclic polymerization. We did this reaction earlier. So what is happening in this case? First, ethine are taken in the presence of, these are the 3 moles of ethine which are taken in the presence of red hot iron tube. The temperature of the reaction is 873 Kelvin. So the temperature of the reaction is very high. So cyclization is taking place. This bond will be shifted towards this. This bond will be shifted towards this, and this bond will be shifted towards this. So there will be formation of benzene will takes place. So by this method we can also prepare mesitylene. So what is happening in that case? So what is happening in this case? 3 moles of propyne are taken. So what is happening? This bond will be shifted towards this. So this bond will be shifted towards this, and this bond will be shifted towards this. So the reaction conditions are same. In the presence of red hot Fe tube, and the temperature of the reaction is 873 Kelvin. So there will be formation of mesitylene will takes place. This is mesitylene. Mesitylene is the common name of this compound. What will be the IUPAC name? 1, 2, 3, 4, 5, 6. So what will be the IUPAC name? 1, 3, 5 trimethyl benzene. Next reaction is decarboxylation. We have studied decarboxylation. So what is happening in this case? There will be removal of carbon dioxide is taking place. This reaction is taking place in the presence of soda lime. So what is happening in this case? This is sodium benzoate. So in the presence of sodium benzoate, when we take soda lime, that is this is the mixture of sodium hydroxide and calcium oxide. This calcium oxide is a quick lime. So this is playing very important role. So because this is behaving as a dehydrating agent, so what is happening in the presence of this calcium oxide? This sodium hydroxide will remain dry. Sodium hydroxide is highly hygroscopic. So in the presence of moisture, it will absorb the water. So what is happening? To make it dry, we use calcium oxide because it is behaving as a dehydrating agent. So if there is any water present in this reaction or produced during this reaction, that water will be absorbed by this calcium oxide. Temperature is 630 Kelvin. So what is happening in this case? There will be byproduct will be Na2CO3 and formation of benzene will takes place. This is decarboxylation reaction because in this case there is removal of CO2 is taking place in the form of Na2CO3. This is descent of series because in this case the product which is formed is having less carbon. It means there is one less carbon in comparison to the starting reactant. So this is a descent of series. Third reaction by the reduction of phenol. So what is happening in this case? This is phenol. So what is happening in this case? In the presence of zinc, dust and heat, so there will be formation of benzene will takes place and removal of ZNO. So this is the reduction by help of zinc dust. Fourth. Next is reduction of chlorobenzene. What is happening in this case? This reaction is taking place in the presence of nickel aluminium alloy and NaOH. This reaction is taking place in this condition. So what is happening in the presence of nascent hydrogen? These are nascent hydrogen, that is atomic hydrogen. So what is happening? There will be formation of benzene and removal of HCl will takes place. Next method of preparation of benzene from diazonium salt. So we will do the reduction of diazonium salt in the presence of hypophosphorus acid and cuprous ion. So what is happening in this case? This is diazonium salt. This is diazonium salt. So the reaction is taking place in the presence of hypophosphorus acid. This is hypophosphorus acid in the presence of water, and the catalyst is cuprous ion. So what is happening in this case? There will be formation of this benzene will takes place because this diazonium salt is very unstable. So what is happening? Benzene formation, removal of N2 and HCl, and there will be formation of H3PO3 is taking place. So what is happening in this case? This H2O will ionize to give H plus ion. So that H plus will react with this Cl minus. So there will be removal of HCl will takes place, and oxygen will attach with this part, that is it will form H3PO3, and this hydrogen, that one hydrogen which is left, will attach in this position of phenyl to form benzene. So this reaction is taking place. This is reduction of diazonium salt. So sixth method of preparation from benzene sulfonic acid. So what is happening in this case? This is benzene sulfonic acid will be heated in the presence of superheated steam. So what is happening in this case? The temperature of the reaction is 423 to 473 Kelvin. So there will be formation of benzene will takes place and removal of H2SO4. Seventh method of preparation of benzene from N-hexane and N-heptane. We have studied this reaction earlier for the formation of benzene and toluene. So what is happening in this case? In the presence of N-hexane straight chain, CH3, CH2, 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 CH3. This is N-hexane. So what is happening in this case? In the presence of catalyst. So in this case the catalyst are oxides. So they are chromium trioxide, vanadium pentaoxide, molybdenum trioxide, which is supported by alumina, that is Al2O3. The temperature of the reaction is 773 Kelvin and the pressure conditions are 10 to 20 atmospheric pressure. So what is happening in this case? First of all, there will be cyclization will takes place. It means there will be formation of cyclohexane will takes place. Further this cyclohexane, there will be removal of hydrogen will takes place. So what is happening? There will be removal of 3 moles of hydrogen molecule. This step is aromatization. So there will be formation of benzene will takes place when 3 moles of hydrogen are removed. So in this reaction there are 2 processes which are simultaneously occurring. First is cyclization and second is aromatization. Next, for the formation of toluene CH3 of this is N-heptane chain. So what is happening in this case? There will be formation of, first of all, there will be cyclization will be taking place. So this is methyl cyclohexane. Further this methyl cyclohexane, there will be removal of 3 moles of hydrogen. So there is formation of toluene is taking place. This is toluene. Next preparation method of arenes by Wurtz-Fitting method. So what is happening in this case? Haloarenes are taken. This is haloarene, this is bromobenzene. So what is happening? In the presence of sodium and alkyl halide, CH3, CH2, Br and dry ether. So there will be formation of ethyl benzene is taking place and removal of 2NaBr. So what is the significance of Wurtz-Fitting over Friedel-Crafts reaction? In this case, the final product which is obtained, we know the structure of final product in the case of Wurtz-Fitting reaction. Second, if there is a longer chain of alkyl halide, then this longer chain of alkyl will directly introduce in benzene without any rearrangement in the case of Wurtz-Fitting reaction, whereas in the case of Friedel-Crafts reaction there will be rearrangement will takes place. Because of that, Wurtz-Fitting reaction is having advantage over Friedel-Crafts reaction. Next reaction is Friedel-Crafts alkylation, ninth reaction, Friedel-Crafts alkylation. So what is happening? In the presence of alkyl halide, in the presence of anhydrous AlCl3 which is behaving as a catalyst, so there will be formation of toluene will takes place. This alkyl part will attach on this position, so there will be removal of HCl will takes place. So what is happening in this case? There will be rearrangement will takes place if there is a longer alkyl chain is present. So if longer alkyl chain is present, then there will be rearrangement is taking place, because this reaction is taken place by the help of carbocation formation, and we know that in the case of carbocation formation, most stable carbocation is 3 degree, then 2 degree, and least stable is 1 degree. This Friedel-Crafts reaction can also be taken place in the presence of alcohol. So what is happening if ethyl alcohol will be taken? We know that oxygen is having 2 lone pairs. The presence of AlCl3 which is behaving as a catalyst. So what is happening in this case? This AlCl3 is Lewis acid, it is electron deficient, so it will attract the lone pair of electron of oxygen. So this lone pair will be shifted towards this, so there will be formation of H3 CH2O H Al Cl3 minus, positive charge will be coming on this oxygen and one lone pair is left. We know that positive charge on oxygen is unstable because oxygen is second most electronegative element. So what is happening? It will take away the shared pair of electron towards itself. So there is formation of this reaction is reversible. So there is formation of CH3 CH2 plus, that is primary carbocation. This is 1 degree carbocation which is formed in this reaction, and removal of AlCl3 and OH. This part will be removed. So there is formation of this carbocation is taking place. This carbocation will further attack on CH3 CH2 plus, further attack on the benzene ring. So it will attack on the benzene ring. So there will be formation of ethyl benzene takes place. So formation of ethyl benzene takes place, and further there is removal of H plus ion. So by the help of this alcohol we can also do Friedel-Crafts reaction. So in the presence of AlCl3 there will be formation of 1 degree carbocation. Further this 1 degree carbocation will attack on the double bond position. So there is formation of ethyl benzene will takes place. Friedel-Crafts reaction can also takes place in the presence of mineral acid and alkenes. So what is happening in this case? Instead of taking ethyl alcohol or alkyl halide, we can also take alkene in the presence of mineral acid, example H2SO4, H3PO4, or we can also take HF which releases H plus ion. So what is happening if we take H3 whole twice C H2, this is 2-methyl propene. So what is happening in the presence of mineral acid? Mineral acid releasing H plus ion. So these mineral acid are H2SO4, H3PO4 or HF which are releasing H plus ion. So this H plus ion will attack on the double bond position because the pi electrons are much more free. So this pi bond will be shifted towards this carbon. Because of that, this carbon will be having positive charge. Why this carbon is having positive charge? Because it is attached with the alkyl group. So in this carbon, positive charge will be more stabilized in comparison to this carbon. So this H plus will attack on this carbon. So what is happening? There will be formation of CH3, CH3, positive CH3. This is 3-degree carbocation which is more stable, and this 3-degree carbocation will further attack on benzene ring, that is C6H6. So there will be formation of C, CH3, CH3, CH3. So last method of preparation of benzene from Grignard reagent. So what is happening in this case? Phenyl magnesium bromide. This is phenyl magnesium bromide is taken in the presence of isopropyl bromide. This is isopropyl bromide, and this reaction is taking place in the presence of dry ether. So what is happening in this case? There is a formation of cumene is taking place. This is cumene. The common name of this compound is cumene, and there will be removal of MgBr2. So this is cumene. What will be the IUPAC name of this compound? This is 2-phenyl propane. This is 2-phenyl propane, which is also known as cumene.